Review of our proof of concept RapidMiner Studio extension called streaming. Let's just get a quick overview of what we're going to do now. This is just, again, a very simplistic use case, but still proves the functionality and the capability of our extension. So here I'm going to produce some JSON data. This is going to go into Kafka topic. Then I'm going to head over to RapidMiner Studio and design a very simple streaming workflow, which I'm eventually going to dispatch to both Flink and Spark clusters. And the result, which will also just be in the Kafka topic, will go into topic B, and I'm going to just simply pull that from my terminal, so I can make sure that the data arrives in a form that I expect it to arrive in. So this is our plan. Let's just check everything's up. So here we have this server called Freya, and as you can see in the URL, I have here Flink cluster, standalone cluster. So I just refresh the page, it's still there. We have some task managers and of course the job manager itself, which is hosting this web UI. We also have a Spark standalone cluster. In this case, I've put it on this board. This is the Spark master, and again, this is also with 3 workers. They're all running in Docker, so I can just scale them up as easily as I just started them in Docker Compose. I'm going to refresh this page. As you can see, we have both clusters in a very idle state. There's no jobs running whatsoever. Okay, so according to our plan, let's just check topic A. So I'm going to go over here to my terminal. Here I have 2 tabs in my terminal. This is topic A. As you can see, I already started producing some data. This is just some made-up data by me. I wanted to have some string data. I'm just going to pause it for a second. I wanted to make up some string data, then have a key, which in this case is a numeric. To be honest, this is also string, but I'm just going to deal with it as numeric data. Some data maskable key, and we have an amount in case I want to do for proof of concept aggregation. But here we're not going to use it because the very simplistic use case, which I'm going to show in a second, is just going to do some filtering based on the key. So as we can see, the data is, if I'm not mistaken, it's still running, producing 1 data point, in this case a JSON, at a time, and the periodicity of that, for the frequency of that, is 1 second. And in the other tab on the terminal, I am pulling currently the result queue and result topic in case of Kafka, and as well, there are no jobs running as I've shown it on the web UI, so there is no output at all. So we're going to change that by designing a workflow in RapidMiner Studio. So I'm going to go to RapidMiner Studio. Here we can see the operators belonging to the streaming extension. There are some, and we can expect some more and further upgrade of these, extending the capabilities of these existing operators in the future. But for now, they're very simplistic. In case of a filter, for instance, which we're going to use now very soon, I always have to provide a key to find the value we're looking for. I'm going to provide the right side of the right operand of this operator, and I can actually choose what to do, like equal or greater than. We're going to use probability less than and greater than in our use case. So I could design it now. I found it a bit helpful to design it in advance so that I don't have to spend too much time on the configuration, because I can mess that up. It's just better if I have it already. I want to point out the connections here. You can define new connections the usual way. We created 3 new connection types: Kafka, Spark, and Flink. Again, this is still proof of concept, so the configuration is very limited to, in case of Flink, just to the host port and the parallelism settings. In case of Spark, I think it also is just the URL, and an HDFS cluster is also running. I forgot to mention that, but we need that for submitting jobs to Spark. So for Kafka, I think it is just the host and port. To be more specific, it just broke a list, so it comma separated a list of host ports. So let's just open one of my POC streaming workflows. As we can see, we always have to design a streaming nest first, which comes with a connection. In this case, I'm using one of the standalone cluster. It's called local, but I've set the Spark master in my host file, kind of just overridden the DNS resolution. I set the local Spark master to the Freya server, so we're gonna see that in a second. So this is a job. We're going to dive into this. As you can see, we have one source. It's here. This is the INFORE test complex transaction, which is the same topic I'm currently polling here internal in the left side. So this is what we're going to source, and this is our sink. And if I take a look at the sink is always the same. It's the complex transaction result. And yeah, for both of them, we have connection objects, obviously, because we need a Kafka connection. And here we have our filter, as I mentioned before. What we're going to do, we're going to set Spark to only filter for keys less than 5. That means 5 keys from 0 to 4. And I'm going to just use 5 to 9 in my Flink cluster later on. So if everything's set, I think we should just start the process. It is as simple as that. So I'm going to start it. In the background, it's going to upload the jar file to an AGFS cluster, and then going to notify the Spark cluster to run this job with the appropriate parameters, in which case we have like a graph, a serialized graph, which is the workflow itself. So as we can see, it successfully dispatched the job. So let's just head over to our Spark master. As you can see, we have running application POC job 1. This is the name which I've given here. So it actually does match my submitted job. And let's just wait for a couple more seconds. Yeah, there are no failures. And if we go here to our result tab, we can actually see that there are actually some data coming in now to a result topic. And the keys are indeed between 0 and 4 inclusively. Although we are actually producing data with 9, 7, 7, 6. So there are certainly keys, I guess evenly distributed among the random numbers, because I'm using a random generator for this. And still we only allow here just the ones between 0 and 4 inclusively. Okay, let's just change that. So we still have, so we have a Spark job running. It's been running for 1.1 minutes. And let's just go to Flink, which is still idle. So we're going to do this very quickly. I'm going to replace the Spark connection with a Flink connection to the Freya cluster, and just simply start it again. This is quicker because the fetcher is way smaller in case of Flink than Spark. So if I head over to Flink, it automatically refreshes its page. And yeah, I forgot to do something. I forgot to change a key, so we're gonna see some doubles here. Yeah, so everything is there twice. So I'm going to just quickly cancel this on the Flink cluster page, and just go here and filter greater than or equal to. So we're going to go for 5, 6, 7, 8, and 9. I'm going to save that, or you don't need to, but I want to, and just redeploy it. Okay, so now we have running this new job, and if I go over here, I should actually see stop without duplicates and basically see just the mirror of our input source, which is this one. So if I go here, I see like these guys, and if I go there to the other topic, I see the same thing, because Spark is providing events with the key from 0 to 4, and Flink is providing the keys from 5 to 9 inclusively. So yeah, I think that's about it. So, and obviously the management of these jobs currently happens on the respective standalone master. In case of Flink, this is the job manager. In case of Spark, this is the Spark master, which provides you a way to handle your applications, the driver, to be more specific. Yeah, I think that's it.